Surface tension of solutions. Let's first discuss what is surface tension. Surface tension is a physical force in the surface of the liquid that arises as a result of the atoms of the liquid pulling off their neighbors in all directions. Surface tension is measured as the energy required to increase the surface area of a liquid by a unit of area. The surface tension of a liquid results from an imbalance of intermolecular attractive forces that are the cohesive forces between the molecules. So there are two types of forces at liquid-air interfaces. Surface tension results from the greater attraction of liquid molecules to each other due to cohesion than to the molecules in the air due to adhesion. The net effect is an inward force at its surface that causes the liquid to behave as if its surface were covered with stretched elastic membrane. Thus, the surface comes under tension from the imbalance forces, which is probably where the term surface tension came from. If we talk about the water have higher surface tension or the highest surface tension among most of the solvents. That is because of the relatively high attraction of water molecules to each other through a web of hydrogen bonds. Water has higher surface tension of 72.8 millinewtons per meter at 20 degrees centigrade. Then that is the highest among most of the other liquids. Surface tension is an important factor in the phenomena of capillary. So surface tension has the dimension of force per unit length or force in a form of energy per unit area. These two dimensions are equal, but when referring to energy per unit area, it is common to use the term surface energy instead of surface tension, which is more general term in the sense that it applies to the solids. In material science, surface tension is used for either surface stress or surface energy. So let's discuss what is the cause or the causes of the surface tension due to the cohesive forces. A molecule is pulled equally around its surrounding. So due to the cohesive forces, a molecule is pulled equally in every direction by neighboring molecules, resulting a net force is equal to 0. The molecules at the surface do not have the same molecules on all the sides as for the bulk molecules. So the molecules at the surface do not have the same molecules on all sides of them and therefore are pulled inward. This creates some internal pressure and forces liquid surfaces to contract to minimum area. The forces of attraction acting between the molecules of same types are called cohesive forces, like attraction between water and the other water molecule. while those acting between the molecules of different types are called adhesive forces. The balance between the cohesion of the liquid and its adhesion to the material of the container or the surface determine the degree of bending. That's why the surface tension is responsible for the shape of the droplets, that is usually spherical in shape, having maximum surface area due to stretching of the surface. While discussing the surface tension of different kind of solution, let's consider three examples that are belonging to different categories of solutions, in which first one is KCl, that belongs to inorganic solute that make a solution of strong electrolyte. Second example is ethanol, that belongs to non-volatile, non-electrolyte solute that is dissolved in the water. And the third category is surface active agent known as CTAB. The full name of CTAB is cetyl trimethyl ammonium bromide. Now let's discuss about potassium chloride. When we increase the concentration of potassium chloride as solute within the solution, so as we are increasing the concentration, the surface tension of this kind of strong electrolyte solution is increasing with increase in the concentration. That is due to the lower concentration of potassium chloride at the surface. As potassium chloride is a strong electrolyte, when it is dissolved into the water, it is dissociated into potassium and chloride ion, which make a strong solvation sphere within the water. Due to these strong interactions with the water, the intermolecular forces that have been developed due to this strong electrolyte are increased. So due to increase in the intermolecular forces or the cohesive forces, there is increase in the pull of inward to make the surface more stretched due to the stronger intermolecular cohesive forces. So increase in the concentration of potassium chloride in the solution increase the surface tension, that implies increase in the surface energy of the solution, which is unacceptable in thermodynamics. When we come to the ethanol, the increase in concentration of ethanol into ethanol water mixture, the surface tension is decreased. That is because of the more number of ethanol molecules that are occupying the surface, because the ethanol have weaker intermolecular forces as compared to the water-water hydrogen bonding. So these weaker intermolecular forces have lower energy to stretch the outer membrane in such a way that the stretching is having a lower surface energy due to the availability of large number of ethanol molecules at the surface of the solution as compared to the bulk. In the case of ethanol, behavior is thermodynamically acceptable. Now we come to the surface active agents known as surfactants. So as the concentration of the surface active agent is increases, the surface tension dramatically decreases. As the number of monomeric forms of surfactant is increases, they move to the surface of the solution, lowering the surface tension. and thus there is dramatic decrease in surface tension with increase in the concentration of the surfactant until a point is reached that is known as CMC or critical micelle concentration. It is the concentration when the surfactants are organized into micelles in order to balance the different intermolecular forces present within the solution of surfactants. So after the formation of micelles, maximum number of surfactants are organized in the organized structures known as micelles, and due to the less availability of the new surfactant molecules that are increased by increasing the concentration of the surfactant are continuously organizing into micelles, so that there is a less deeper curve showing the decrease in the surface tension with addition or the increase in concentration of the surfactant after CMC or formation of micelles. So it means that before formation of micelles, the addition of surfactant to the solution increase the surface concentration of surfactant. Thus they act as an agent to decrease the surface tension of the liquid. So by increasing the concentration before CMC, all of the surfactant molecules are moving at the surface, lowering the surface tension to a steeper curve or the sharp decrease in concentration until a point of CMC is reached. After CMC, the increase in concentration will increase the number of micelles instead of the movement of the surfactant molecules to the surface. So this is why the surface tension of the surface active agent is slowly decreased after formation of micelles or at the point of CMC. So in this discussion we have seen three groups. KCl belongs to group 1, ethanol belongs to group 2, and CTAP belongs to group 3. Group 1 increase surface tension as concentration increases, hence increasing surface tension energy, which is thermodynamically unfavorable. To decrease the surface tension energy, the number of species that are present at the surface are decreased. It means the species are excluded from the surface. That's why the surface tension or the surface free energy is lowered. This phenomena is known as negative adsorption. It means the number of particles that are occupying the surface are decreased. The example of this kind of surface behavior, the different kind of inorganic salts like potassium chloride, sodium chloride, and many other salts are categorized in group 1 because they decrease the surface species and increase the surface free energy. So the examples of the group 1 are also known as strong electrolytes because they generate stronger intermolecular forces or the cohesive forces, so the elastic surface is stretched towards bulk of the liquid with more power. Now let's discuss about group 2. As the concentration of the group 2 is increased within the aqueous solution, it reduces the surface tension and hence the surface free energy that is known as gamma A. Gamma is the surface tension and A is surface area. as gamma, or the surface tension, is equal to free energy per unit area, or the surface free energy per unit area. So if we talk about surface free energy, we have to write gamma A, means surface tension into surface area. As the increasing the concentration of group 2, as we have discussed in previous example, like ethanol, increasing concentration of the solute, that is non-volatile, non-electrolyte, it reduces the surface tension and hence surface free energy. So by decreasing the surface free energy, which is thermodynamically favorable, hence the concentration increases at the surface. So the concentration of solute increases at the surface due to thermodynamically favorable process. As the number of solute particles, or the concentration of solute, is increasing at the surface, so the membrane become less stretched. With more number of solute particles at the surface, it results a positive adsorption. In previous case, the number of particles that were present at the surface are decreased. They move towards the solution because of stronger intermolecular forces, or the quasi forces within the solution. The number of solute particles are less, or the overall number of particles are decreased at the surface, resulting increase in the stress at the surface, or increase in surface tension. So as the number of particles at the surface are decreasing, this kind of decrease is known as negative adsorption. Examples of the group 2 includes alcohols, alkanoic acids, and amines. So these are known as non-volatile, non-electrolyte solutes. Now move to the group 3, that is actually the subgroup of group 2. Why? Because for group 2, the surface tension decreases with increase in the concentration, as for the case of group 3, which show a different behavior. These kind of solutes reduce surface tension drastically as their concentration increases up to a point that is again represented here as CMC. So thereafter, concentration has hardly any effect on surface tension. So these kind of solutes are known as surface active agents or surfactants, having a long hydrocarbon chains and a polar head. So the polar head is usually carboxylic acids, amines, tertiary amines, sulfates, or any other hydrophilic head group. So the polar end is known as hydrophilic head group, and the non-polar end is known as